Welcome to today's webinar. We're super thrilled to have you today on board to talk about one of our beloved topics, which is AI agents in engineering. And you probably have seen already the last two webinars in this series. This webinar is a little bit different. So we will look under the hood and we'll create together our first agent that will help us to do real engineering work. And for that, I'm super excited to have an expert here on my side. First of all, also hello from my end. So my name is Daniel, co-founder and co-CEO of Synera. Most of you people already know me. And as mentioned, I'm not alone. I have our head of AI with us. I'm super thrilled to have you on board, Ram, and really to do the heavy lifting later in the webinar. So please say hello.
Yeah, thanks, Daniel, and hi, everyone who are joining this webinar. It's my honor to do this with you, Daniel, and also give a tour of how building an agent in Synera looks like and excite you to build your own agents in the future.
Cool. Yeah, I was also super excited to have this session together with you. I know how often we work closely on this topic, and now we can also talk about this topic more and more. So yeah, super excited. Some mechanics here for the meeting. We really want to get the most value for you guys out of this session. So whenever you have questions or something is unclear, please use the question system inside of Zoom. If it fits to the current content, we will try to clarify questions directly at the spot where we are. If not, we will have a dedicated Q&A session at the end of the webinar, and hopefully we will get everything answered. Our goal is that after the next 45 minutes, you really get a better understanding about what is an agent, how to build an agent, and how you can utilize and use agents in your daily work. And as the audience is normally very diverse with a lot of different pre-knowledge, we would start with a little exercise, also like an icebreaker for you guys, and also to see where we are here in this room. So we prepared a short question, like a first icebreaker question here, where we would love to get your engagement here. So please take your phone and scan the QR code, and then you will directly route to the questionnaire of today. There will be multiple questions during this presentation, so we will see a little bit how the current situation looks like. And if you don't have a phone here, I think, Ram, we can also paste the link into the chat. And so let's see. Oh, interesting. ChatGPT is definitely one of the most used one, probably custom GPTs. Let's see. Interesting, there are 6 others. So it would be also interesting later if you can share your experience here and so in the chat. Would be also interesting for us, which kind of frameworks you're currently using for agents.
Musa says GraphVid. That's really nice.
Cool. And we still have a large group of audience here, which never really build agents on their own. So I think, especially for you guys, that will be also hopefully a very valuable session. Okay, then let's get started. First of all, we have to clarify the question, why are we want to build agents, right? And especially in engineering, we have a lot of huge challenges. And they are there for a long period of time already. But now with agents, or in general, the AI transformation, for the first time, we really have the possibility to have a huge impact here. So let's go from left to right. So what we see is still in engineering is we have a lot of talent shortage. That means a lot of open job postings. A lot of engineers are still missing to really do the development that is needed for the consumers who want to consume the innovations of tomorrow. And also we see that with all the technology and the speed in the market, the consumers, they want to get product faster, right? We see it with, especially in the automotive market. I mean, probably when I open my LinkedIn feed, I see it every day. It's like, okay, there are companies out there who can develop cars in 18 months. And there are companies out there who still need 3 to 4 years for a car. And it's definitely a competitive advantage if you can be more productive. And the question is a little bit, how can we change the style of work in a way to really compete in this competitive landscape? And then probably the third one, which everyone here in this group already have experienced by themselves, is you do a certain task, you have a certain work to do, but you have dependencies. You need some pre-work from another co-worker, or you have to wait for some supplier, and you cannot really continue because you have the dependency. And especially these bottlenecks, because engineering is normally a very complex environment, is a situation where we get massive slowdowns at the moment. And if we want to overcome this, we have to make sure that we can utilize these new technologies like agents to also reduce bottlenecks and spread the expertise to more shoulders. But not all of all the tasks we're doing at the moment are perfect suitable for agents as today. So it's really important to select the right starting point and see what are the capabilities of agents today and where I can already utilize them in the right order. And for that, I'm super excited to get some insights here from Ram, because Ram, I think you worked the last 6 to 12 months almost daily in this field, and I think you have a very good observation already, and you can sum it up here to give us some insights. What would you suggest here? What kind of tasks are suitable for agents?
Yeah, thanks, Daniel. Yeah, like you mentioned, engineering is pretty complicated, and there are different nature of tasks, and there are different kind of problems I have observed our engineers tackling. It could be as simple as talking, but it could be as simple as also responding to a 20 million euro RFQ. So it's a wide range of tasks, and we try to help or we try to use solutions across also a different range of complexity and power. And I think it's a good category to rank these things would be to see how human-like are these systems versus how autonomous they are. If we think about a rule-based workflow, it's pretty standard. It does a specified set of actions. There is not much autonomy because a human is needed in the loop to automate it. But when it does the automation, it's pretty straightforward. It breaks less. There is not much what we call fussiness. It's not random. And there is a different kind of bridge called the AI enhanced workflow, where it's still a standard automation, and one part of it is AI driven. It could be a machine learning model, it could be a deep neural network, it could be a convolution neural network for image classification and so on. But we still see that the autonomy is still on the lower end because we still need humans to trigger this. But when we talk about agents, the word itself signifies there is a huge amount of autonomy involved. And agents are specifically more suited to act more like humans because they have the brain, which is the large language models, which we will talk about, and they are more focused on one task. But the beauty, or what we have been working on for the last 12 months, Daniel, we also had a lot of insights around this, is when it goes to the multi-agent system, we see huge success in terms of having focus on narrow tasks as well as covering a wide spectrum of tasks. And this is kind of a benefit where we can get both human-like nature and the automations are autonomous. And I think for today, we will focus on the AI agent or a singular agent. But in my experience, building one agent is useful for multiple teams. For example, one CAD agent or FA agent can be part of different streams. And there is also high frequency associated with agents because they're always up. But what are your thoughts, Daniel, and how do you see it?
Completely. What I see especially is that in the whole field of AI for engineers, you have a lot of different technologies around there, right? And this map always helps me a little bit to see the light in the fog, because an AI enhanced workflow is completely different than a multi-agent system, right? And I think especially over the last couple of years, we talked a lot about AI enhanced workflows like this. Can I use prediction instead of simulation, right? Like probably you've heard about the term reduced order models. But now we want to shift the focus a little bit more to a completely new field, which is the way of how to use AI for having really an agent as a sidekick. So I'm super thrilled to have this the main topic of today. And today we will handle one single AI agent and how to build it. But as you know, it's very tricky to find the right use case. You see it already here a little bit in the map. And it's way too much to have this also in this webinar. Therefore, I want to teaser a webinar that we did last time is where to start, right? How to find the best use case for AI agents and later also for multi-agent systems. Also to make sure that you have a fast-track success inside of your companies, right? Because the technology is a certain state of the development, and to really make sure that you can already utilize them in a way that you get a competitive advantage, you have to make sure that you find the right use cases. And for sure, they will be better over time. Okay, then there's a next short Menti. So please get your mobile back into the hand. So the question is a little bit, where do you think the most, let's call it full, useful impact for AI agents? Where do you want to apply these AI agents in your daily world? What do you think? So now you have to guess, right? So I also have to get my mobile here.
I hope the link, let me also paste the...
It's working, we get the first. It's also, can also select multiples, right? So we'll see a lot of results here. So a lot of simulation folks who would love to have simulation agents. I think we can tease that already, right?
True. I also see CAD and cost almost kind of competing.
Interesting. Yeah. I really like this graph because hopefully after the session, you also get a better understanding, okay, which column you should tackle first with the current status of the technology of today, right? Because there are columns here which are much harder to solve today. And there are columns where you say, okay, that is a quick one in a honeypot, right? And yeah, and very good. I mean, the best handover I can have here is the winner is simulation. And today we thought about, okay, what kind of agent do we want to build, Ram?
Yeah, I think we almost got it right. So today we want to build an FE analysis agent. And this agent should be able to, let's say I'm a CAD designer. This agent is going to help me act and perform the tasks of a FEA engineer so that I don't have to wait for a real FEA engineer to help me evaluate my designs and so on.
And why is this so important? Last year, we already had a webinar around this topic, democratizing FEA knowledge, right? How to empower CAD persons to make more FEA. And what we saw in this webinar is also after the poll is that there is still an unbalanced ratio between designers and simulation experts. So there's up to 4 CAD requests to one single simulation guy. And in our daily work, when we are talking with customers, it's even up to 10 to 1. So that means there's a lot of pressure on the simulation department because, I mean, they have to act very fast to give fast feedback to the designer to make sure that the designer can make an informed decision on design changes. And what we see in reality is still this chart here. Yeah? The designer starts with incremental changes of his geometry, then set up, okay, I want to get some proof point from the simulation experts. The simulation expert has a backlog because he has to handle a lot of different tasks. And then maybe after a week, he gets the response back, maybe a PowerPoint, whatever, how to make a meeting and to give the information about the analysis. But the designer is not waiting for it, right? Normally, he's just starting over and over, and there's already a mismatch. And this is exactly where we want to give the simulation expert here a sidekick, like a digital coworker that he can or she can use to really scale his knowledge or to reduce this bottleneck, as we saw as one of the biggest challenge. So today we really want to create a digital coworker together, which is able to perform 3 different tasks. So 1, the agent will be able to understand the requirements, like the load case specification, all the stuff that is needed. 2, the second task, apply the boundary condition, put the material specs on it to make sure that they can perform a whole FEA analysis. And then the third step, which is also still very important, is to interpret the results, right? And to make sure, okay, how to summarize the whole simulation so that the CAD designer can really benefit from it. Before we dive into the software, we want to start with the general introduction of a single agent. So we already mentioned it. You can think about of an agent like a digital coworker, someone that you can use side by side to hand over some heavy lifting and say, please help me with my work, or please support me here and there. But to bring this agent to life, you need specific ingredients, specific things that build an agent up. And what are the most important ingredients we need to create our own agent here?
Yeah, that's a good question. And especially that there are different definitions of AI and agent. It's super nice to be on the same understanding, especially in this round of amazing people we have. And the first ingredient is actually a large language model, which is basically an AI model. And this is powerful, or this is almost the brain of an agent, because it can do two things which are very close to humans. That is communication, talking to other agents, talking to humans, communicating kind of thoughts and ideas, but also reasoning. I mean, like you, Daniel, my LinkedIn feed is also filled with AI, and we see huge advancements in how the large language models can reason on different spectrum of tasks, on logic, on capabilities. And I think this is a very powerful capability that if we add on to agent, we increase the general, what we saw earlier, the fuzziness or the human-like behavior. The second one is basically the instructions. And we will also talk about this, what they are. But even if we use a large language model, we need to make sure that they are responsible in a certain narrow domain of tasks. And even if they have a wealth of knowledge, we want them to be accurate in a specific domain and be tuned to know what is required to do their job well. Now, again, getting inspiration from humans, there is also memory. And this memory is usually super helpful when we put these agents to production. So as the agent is on the job, it goes through hundreds, thousands of conversation. We can equip with these agents to learn from the conversation and be better. And this is really powerful when we talk about agents in production. And today we want to talk about building our first single agent. And the last ingredient is actually engineering tools, which is where Synera is kind of poised to. And the large language model in combination with instructions, memory are at the core manipulating tools. And engineering data is super unique. They are varied, they are across sources. And that's pretty much why we need an agent paired with instructions and an engineering tool. And that completes actually the skeleton or the base of an agent.
Cool. So to sum it up, we need 4 ingredients: a brain for a large language model, instructions, memory, and access to tools. And to give you more details, we want to cover all of these in more depth. So let's start with the brain, the large language model. And you probably have heard a lot of different large language models, like probably the most famous one, OpenAI, right? ChatGPT 4.0, or you have like the Claude. But they're all different and they all have strengths and weaknesses. So it's really important to select the right brain for your agent. And to tell you more about, Ram has great insights here how to find the right brain for your agent.
Yeah, that's correct. I think as engineers, we have also a wide range of tasks to do. And there are different lenses to look at large language models, but one that's really powerful for or useful for, let's say, human engineers is the intelligence itself and the modality. And modality means what kind of data types can they manipulate? Is it just text? Is it also images? Is it also video? Can they also interact with mesh? And the second axis is intelligence. Is it just a bot that can just talk to us, or can it also have the reasoning ability to think about the outputs? And the first task that's on this quadrant of this graph is like writing a report. We only need the capability to write a report, maybe get some inputs, and write a specific report. And we have some models like Llama, GPT-4, or Claude 3.5 Sonnet, and there are different ways to measure this, but these are like common models that are very good at writing not just engineering reports, but also in stories in general, if you want to play at some point. The second kind of things are where the intelligence needs to be high and the modality kind of is limited to one thing. So imagine classification of geometries. So these are usually the multimodal models like GPT-4o or the more recent Gemini 2.5 Pro, which are really good at a specific narrow task if we prompt them well. And the third one is basically where the intelligence can be less when compared to the kind of modality needed. So if it's a complex tool like processing text, processing images, processing documents, then when we need a multi-tool like GPT 4.1 or a Gemini 2.0 Flash that are very poised at calling multiple tools, remembering the context, and giving right answers. The last one is basically combination of everything, analyzing the FE result image. And in my experience, to analyze a FE result, we have to tilt the geometry, look into the hotspots, really identify what's happening and give the feedback. This is a combination of intelligence and modality. And there are certain models like GPT-4o, which we will also use today, that can help us in covering some of the tasks. And that's pretty much about large language model, Daniel.
So I understood you can have specific or different brains. So what is the best starting point? What is your current go-to model when you have to start from scratch? Are you normally using this graph, or do you start with a specific one and then iterate from that?
I usually start with GPT-4o because they were one of the ones to first launch access in terms. So I love how fast they iterate and can act faster. But also the amount of tasks that GPT-4o can handle is really amazing. It still tops on the leaderboards or the benchmarks, and OpenAI is constantly building new models. So my go-to model is GPT-4o. But again, that's where engineering comes into play. If it fails, then we have other models who are more specific to a certain task. For example, writing a report, I don't want to spend as much tokens like GPT-4o. I could use a simpler model. So I think it's an engineering optimization problem at the end.
And this is the beauty, right? You can start with one model and you can change it next week if you want and see if your system gets better and smarter. And as we see that the whole system is like, I mean, every week there's a new paper coming out, a new model is getting fine-tuned. So it's really plug and play, and you will see it now when we go into the software and show you how to, build your first agent with a brain. Oh, there's one question maybe we can already answer here because it fits very well is, which large language model would you recommend if you want to build it locally, so on-premise?
Interesting. I think when locally, it's a quite kind of opposite. Like start with a model that's smaller in size, like a 3 billion parameter model, like Llama 3 billion or 7 billion, and try to host and see if the task is solved. And then scale the model size to host for bigger usage and everything. So I think local is a kind of a different view. We start small with smaller models, especially local hosted. We need a lot of power, compute, and then I think we can scale it one by one there. I think that would be a good way to do it, but it's a good question. I think a lot of our customers are also doing the same way.
Yeah, normally they have these three different kinds, right? They use just the OpenAI services as is, or they use it inside of their Azure or AWS tenant, or they go even one step more into the let's call it on-premise world where they really host it locally.
Exactly.
Cool. Then let's get started and bring the brain into the agent, Mr. Ram.
Sure, awesome. So for those of you who have not seen Synera, Synera is basically a low-code automation platform. We have nodes, we put them onto Canvas and connect them. So let's build our first agent, or let's say just give our agent a brain. So we have a bunch of nodes that cover the whole engineering spectrum of tasks. And I find a node that's basically a supervisor. And this is going to be the agent that we will use. So I will rename it FE agent so that at the end, everything revolves around this agent. And after I rename this agent, I see there are certain options or certain inputs that I can equip this agent with. And the first thing is a large language model. And you see here, we have 3 options to pick from: GPT 4.1, 4.0, and so on. And I pick 4.0, and you see the agent is almost up to life. So it has a brain now, and it's ready for getting its next ingredients that we talked about.
It's crazy, or I mean, 3 clicks and the agent has a brain. And if you have a new model out tomorrow, you can just change it and you get a smarter brain. I mean, how cool is this? Okay. Then next is, so we covered the brain part. Now we have to give the agent more purpose, more what is his role? What should the agent do, right? For that, we have the instruction. And there's not just one single instruction. You have to think a little bit more specific how to really bring an agent to life. And for that, we want to give you some more insights here how to really instruct your new agent.
Yeah, happy to jump in again, Daniel. And I think when we think about this instruction, it's actually there's a separate term from the developer world called prompt engineering. And again, the question comes, what does it mean for engineering agents? And I think as engineers, it's not just one specific task that we have. We have to tackle different things at different time. We need to innovate, but also we need to do repetitive processes again and again. So it's kind of how do we encapsulate this personality of an engineer onto an agent? And this is where prompting just helps because it's such an effective way to communicate what needs to happen. And in Synera or for engineering agents, there are like 4 main categories of text or prompts that helps an agent behave well, let's say. The first one is responsibilities. And this is kind of the core what the agent is really capable of. So when we build the FA agent, we will see how we define the responsibilities. The second one is a goal. And after equipping with a responsibility, just like humans, we are all every day working towards some goal, be it in task or be it in a project. It could be to lower the cost or make sure the design is handed off properly. And there are different goals that the agent can also get. And usually when we are in a multi-stakeholder project, there are always certain, let's say, rules that the agents, if equipped with, are better. For example, how does it always evaluate? So should it be through the guess of an LLM or should it be by executing a workflow or a tool? And the last one is a role description. And this is kind of what others get to know about this agent. And this is like, I know what you do at Synera, Daniel, and you know what I do. This is because we have titles, we have a short description of what we do. And this is basically what we try to encapsulate in a prompt or in instructions. And that is what we will saw later in the demo. But I think, Daniel, you once gave us good insight of how to think about these prompts or instruction, especially for people new into this field.
Yeah. We have learned that these prompts are really mission critical, right? And it's really important to come up with the right words here. And the good thing is that most of our companies that we're working in this field already with, they already have great resources they can utilize for creating these instructions. And you can think about what is a good resources to utilize. One is, for example, your job specification or a role description, right? So most of the engineers, they have a specific role description or a job spec or whatever. So this is a really good resource that you can utilize to grab information out of it and put them into the instruction. The next one is maybe you have standard of procedures inside of your companies. So what we have seen as customers is really that there's already a lot of content and knowledge available that you can now utilize for building your agents. But I think now it's time to really see them, right? How to bring this into into our agent with the brain, but we are still having a lack of the instruction here. So how can we add the instructions now?
Exactly. And just as previous step, we will now simply add our prompts here. And as soon as I expand this node, I see the 4 different categories of prompt we talked about popping up. And usually there are some ways to kind of prompt it in a better way, but the best strategy is always to start simple and then optimize the prompts. So what we do here is I just type in, you're an AI agent that helps a user understand, perform, and interpret FE analysis, because that's what the agent that we build at the next step would be. And whenever a user provides an input, analyze the full problem first, and then decide how to act. And one goal, or actually the only goal for this agent is to act as a FEA engineer and to call the right tool, which is kind of critical. And one of the rules, like we saw previous, was to always explain and interpret the output from a tool call and not to assume any stress values or any kind of KPIs at the end. And for any agent that will be later plugged on, so this is kind of already a teaser. So this is where this prompt is useful for multi-agentic systems. But now, in less than 2 minutes, we already have our agent, let's say, more focused on one specific task that can act as an FEA engineer. That was how you could prompt in an agent, Daniel.
Oh, and there's a good question popping in from Gunnar. The question is, I mean, you start small, as you mentioned, right, Ram? But the question is a little bit, what is in your experience, how often do you have to refine the prompt, and how do you have to make your like improvement of the instruction and prompting to really come to the desired outcome that you would love to?
I think the one that we will show today, I think me and one of our team members, we iterated 3 times. So we've started with a simple like blank 1-line prompt. We saw how the edge cases fail. Then we tried to do one more loop of adding certain elements. And I think the third one was just fine tuning these kind of rules of not assuming anything. And then I guess in 3 iteration, I think it was possible. So I think this is also one of the learning that we had. So when we first started, we tried to put a lot of tasks onto single agent, and we saw they fail. And then we split it into a multi-agent system. So there are also some rules of making the agents focused and having little iteration as possible when building one. And I think that's a good question, and that's why it's called prompt engineering, maybe. So it's an iterative process.
And probably could be another deep dive session, right? So
Exactly.
also we are super curious about if you have specific topics where we should really put another deep dive session on. Happy to get these requests and cover them in one of the later series sessions. Okay, but then we want to give agents, beside the instruction and the brain, we also want to give them power to engineering, right? So we want to give them access to tools. I mean, when we look at our daily routines, we use a lot of different software tools, right? A lot of different technology we are using inside of the PC to make sure that we can do our work. And the most obvious one where we are like, yeah, general purpose tools, right? Word, PowerPoint, Excel, the whole office here, right? As I'm still impressed how much we do in engineering still with Excel, right? I think this is like every industry has this, no matter if we're doing airplanes or ships or whatever. But yeah, the question is a little bit around how can we connect this, right? How can we bring tools into the agents?
Exactly. And I think we need to kind of also understand why is it problem? Like, why is it not so simple to just upload an ANSYS model or upload a CAD model and ask context? Because LLMs are not natively trained for this. So they are more trained for general purpose applications, and engineering data is very unique. And there are a lot of, let's say, results that are hidden behind one FE model. Like when I was first learning FEA, there were like 10 different stress types hidden behind one model. And it's hard for a model to kind of read through them, kind of understand what is the key parameter that I want to extract. I think that's where the key missing piece with today's LLMs are. And yeah, to enable this interaction is where Synera comes into play. And maybe you want to add your thoughts of how you see this tool as a missing piece, Daniel.
Totally. I think the tool layer is really open the agent to a world of doing productive work for you, right? And we saw it in the first survey that some of you already have experience with other agentic systems, and most of them cover more, let's call it a general purpose task like screen my inbox, write me a draft, or set some appointments, some general, let's call it productivity stuff. But as Ram mentioned, engineering is different, right? Engineering is very complex, a lot of desktop software, a lot of legacy tools that you need in your daily routines. And the question is, how can you make them agentic ready? How can you prepare them in the way that the agent still can help you in doing your job by using the technology you already have on your PC? And here I see also a lot of interesting things coming together when you put process automation as tools for agents. And yeah, Ram prepared a brilliant demo for that to give you really a hands-on experience here to see how you can now, when you remember the task we want to achieve with the agent, how you can create the tools now and provide them to the agent. So let's dive in.
Yeah, thanks, Daniel. So again, to recollect, we had four, let's say, tasks or three different concrete tasks. So the agent had to interpret a document. And what we will also additionally do is give a guideline to the agent, which is kind of cool because when we see FEA engineers, they have this best practices always with them. So we will see a tool, how that can be utilized, and two tools which are extremely focused on FEA. So let's start jumping into them. This is our first tool, and the goal here is to kind of utilize this best practices guideline that we talked about. And let's jump into one step by step. So the first part of the workflow that the agent will use is set the input, which is a type of component. And here we use the OpenAI assistant to build our, let's say, bot or an assistant that's super focused on one task, which is to read through the best practice document and identify a best practice. And then we post-process it and we see the output is mesh size and required load step. And in the same way, we prepare another document processing tool. And here it's basically the load case document. So here is a whole document coming as an input. And in the same way, again, we create an OpenAI assistant. We add some prompts. We add some JSON structures to make this work very well. And then we ask this agent or assistant. And at the end, we get all the force values that we need for, let's say, different cases. And the next two tools are really FEA focused. And the next tool is basically a linear analysis tool. And this is one of the most common load steps. And for this tool, the inputs are basically like, let's say, a suspension body or a solid body, but also the element size that comes from best practices. And for those who are new to Synera, Synera is, again, a process automation platform. So what we do is kind of build the whole process of doing an FEA analysis, like applying forces, applying boundary conditions, doing fixed displacement, setting the input forces. So these are some tasks that are better to be done on a rule basis and let the agent focus on other tasks. And that's why, for example, running the solution itself or the FEA solver, we do this in a rule-based fashion. And at the end, what the agent gets are just stress result. And the same way, a model analysis tool, which is a very common load step. Again, we take the same inputs, but we change the load setting a bit here. And now it's a model analysis, not a linear analysis. And then we again do it as a solution run via workflow. And the output is basically a list of eigenfrequencies for the model analysis. So what we see here is already tasks that agents are not doing. So it's setting up a model, it's using a rule-based workflow to do these repetitive tasks. And what the agent is actually doing is coordinating when to call when. How do I understand which tool to call? We also have in there some assistants who are narrow focused on certain tasks, like just reading a document or just suggesting best practices. And I think that's a very important distinction of using tools. Any
Cool.
thoughts you want to add, Daniel, or any questions?
Yeah, to sum it up, so we have a brain now with this large language model. We have the instruction with the 4 different layers to make sure that the agent knows to do. And now you showed us how you created 4 tools, or in our terms, workflows, that the agent now can use to make the work, right? And what's also interesting, you saw on the first 2 tools that you created, there are AI enhanced workflows, right? You saw these tasks, send it over to OpenAI. That is the thing, when you remember the graph from the second slide, is that is something where we use AI for creating a more powerful tool for the agent. But it's not the agent itself. The agent will use this tool later, and we will see this now, right? So how can we put the missing piece to the agent and bring the agent to life?
Exactly. So in Synera, we usually publish these workflows. And once we publish them, these are then easily available, not just to agents, actually, to anyone in the whole company. And now we will focus on agents here. So let's pick up from where we left. So we had an agent, we had a brain connected, we had it prompted, and now the missing piece was tools. And that is what we will do now. So we had published all the tools before, and now we would like to connect them to the agent so it can use it. So Again, I try to put a Synera run workflow tool, and you see there is also a certain additional instructions that we can pair with this. So I quickly find from my bunch of workflows all the tools that I want to equip this agent with. And also this can be a wide spectrum. It can be one tool, it can be 5 to 6 tools. Again, it depends on the model complexity. But we see here, I already connected my first tool and I added a certain instruction when to use this tool. And in the same way, I connect my second one, which is the best practice analysis, which we first created. And I want to tell the agent, when do you use this? And I prompted use this tool to identify recommended, let's say, boundary conditions or mesh settings. And now the agent will know that if I need a mesh size or boundary condition for a certain part, I can use this tool. And in the same way, I also attach all the other FEA tools we created. And this is the linear static analysis. And again, a simple instruction when to use this. So a pattern is we use a tool, we just add a simple hint when to use this tool to an agent. And Synera takes care in the background how to interface with all these tools and easily connect them to an agent. And now I'm almost done setting up all my tools, and I want to just connect them to the one agent. So this agent now finally has 4 different tools, LLM, it has an instruction, and now it's ready to go basically. And that is what we will do. Let's just add a short name. So I'm just going to call it, for example, Synera's FEA Digital Engineer, that anybody in Synera can use if they have a part that they want help with. And to make it just helpful, let's just call it or describe that this agent can help us understand, let's say, FEA requirements and identify best practices, and also maybe simulate them in all together. And that's basically everything. So let me save this workflow. I save it locally. And again, we could publish it onto a server. And that is what we will do now. So I just published this workflow and I see that everything is okay to go. So we are almost 1 second away from bringing this agent to life. And now we have this interface where we actually see nothing behind what's happening, but rather we get this experience of talking to someone. And the agent comes back to me saying, I'm an AI agent specialized in finite element analysis. I can help you in understanding, interpreting, and I have access to these tools. If you have any questions, assistance, or need assistance, feel free to ask. And let's see what the agent is capable of. Let's ask, what inputs do I need to send you? And it's telling me I need basically a load case document. If you have a separate, or it says practice guidelines, which we already attached. And there's 2 tools which it has, which is the linear static analysis and model analysis. Let me know which analysis you would like to perform, and I can guide you. And one of the common, let's say, repetitive simulation process is at what we saw at different things where like NVH components or suspension components. So let's just send this in and see what happens. So I would like to send, or I would like to perform an analysis on that suspension part. Let's also attach a requirements document, which actually tells all the load case needed for this one. So I just pick these 2 documents. So I pick up a Parasolid file, and you see a Word document. These are now the inputs to the agent. Let's hit send and see how the agent is working. So it says the computation is in progress. So the FEA agent is first understanding the requirements. So it's setting the input, and it's getting all the force needed. And then it's also seeing what are some best practices it has to adhere. It sees that it's a suspension arm, recommended mesh size is 5 mm. It has to do a model and linear static analysis. And then the FEA agent probably will go through all of these outputs. It will make sense of it. So what it's actually doing is understanding what it needs to do next. It's kind of reasoning and then thinking, okay, I have everything needed. First, let's start with the linear static analysis because that seems to be more critical. So it already called a linear static analysis. It's automatically setting inputs, making decisions. And then we also have input set, and we have the outputs coming from the linear static analysis tool. And we see the output is a maximum font misses stress. So in less than 3 minutes, we have our first, let's say, insight into this part. And it says the maximum form resistance stress is 404 megapascal. If you have any questions or need additional analysis, feel free to ask. And usually, because this is a suspension arm, this is one of the most critical things. And now we can also ask it to do, can you help me identify the eigenfrequencies of the part? We can, like with the model analysis. And then it would not do everything again. It would just pick up where it left off because it knows all other context. So it knows that, okay, this was how it was before. Let me just directly start working on the other things. So we see it directly calls the model analysis, and it kind of retrieves all other information from its previous, let's say, conversation and puts it into this tool. And now model analysis is running, and hopefully in a few seconds, as this is computed, it will interpret what this means. So it says, here are the 3 eigenfrequencies measured. And I mean, okay, these are numbers. I would like to know what can I do with it. So I just want a quick feedback because I want to know if I can keep continuing the CAD or not. So I can just ask a question considering the stress and eigenfrequencies. What do you think about the design and the safety? Let's say that's one of the primary factors. And once I send this in, now the agent has to kind of summarize all the findings. It has to help us decide what to do with this. So it thinks through a bit, and hopefully in a few seconds, it can give us some insight. So it says, to assess safety, it should be actually compared with materials yield strength. The design is likely safe under specified condition. And the eigenfrequencies, it's important to ensure these frequencies do not match with vehicles' operational frequencies. So if we had another tool to identify this, it could have also automatically used to check, is this matching with vehicles' operational frequencies? So it gave us some next steps to do, but also one quick feedback. I think it took basically 6 minutes to get this first insight. So no need to ask another fellow colleague or no need to trigger any automation. Just talk to like a fellow coworker and it helps you get first insights. What do you think about this, Daniel?
I'm still impressed, right? I mean, what you have shown now, and I don't know, 10 minutes of building the workflow and making all the ingredients yeah, live for the agent, and now also interact with the agent, really cool to see. I think this is just the beginning, and we will see a lot of things in the future, right? I have to look a little bit into the time, so I see we have so many exciting topics here, and also we have a lot of questions I would love to answer in a second. So let's summarize today's session, right? So we started why we should work on agents in general, and also how to start, right? What is a good use case? What is a good thing to start first to really get a competitive, yeah, what is it? Like in a competitive advantage already today with the technology. Then also it's very important to have the ingredients for your large language models, like for your agents. And it starts with the brain. This is a large language model, so select the right brain. Then how important is it to have the right prompts? We learned today you probably need to refine 1 to 3 times, maybe even 4 times, let's see. But start small and get the first system running. And then it's all about getting access to tools. And as engineering is so complex and so diverse, and we do not want that these large language model predict stress results, right? We still want to trust an airplane when we are in the air. So it's really important that we give them the same tools that we already trust today for making simulations and all the stuff. So as you have seen in the chart, we just talked about one agent, right? And you can already guess what our next session will be, right? So if you have one agent, how beautiful could it be if you scale it to multiple agents and come to whole departments? So if you found this session really interesting, so stick with us in the next session. You will see how you can not just use one single agent, but build a whole multi-agent system. It will be also an hands-on session, so you will see behind the scene how to assemble whole departments. But we do not want to close the session before we answer some of your questions. And there are some questions pop up during the last couple of minutes. So let me go through them. So there's one question from Giuseppe. So an AI agent can interface with different tools, but what tools are already available and how can you build them?
Yeah, I think that's why I think we have this marketplace. So there are different ways to interface with them. And at least in Synera, I think we are connected to now almost 70 tools across additive manufacturing, FEA, CAD, and so on. And the beauty of having this marketplace is it's actually the same process. You just drag and drop a node, you connect it to a workflow and connect it to an agent, and the agent already can interface to the tool by setting inputs and outputs. But I think there are also other things popping up with different technologies, which kind of lower the barrier and higher the ceiling, which we always have a motto as in Synera. So I think the interface mechanisms are evolving a lot, but I think a marketplace from Synera is a great place to start to quickly interface these.
Yeah. And with the power of this low-code language in Synera, you can package these kind of technology in a way that you can use them as a tool, as you have seen today. And there was this question about, okay, what kind of CAD and CAE, I would say all major CAD formats or CAE solvers are currently covered. That means from NX to CATIA to Autodesk technology to PTC, but also when you look at simulation, Nastran, Abacus, Dyna. So really look at marketplace.synera.io, and then you get a glimpse about what kind of technology is available as node. And as you have learned today, you can convert these nodes into tools, and the tools can get granted to these agents. Okay, and then there's another question from Luca. Oh, Luca is already a user of Synera, so he worked on cable routing, and he already have a larger workflow with a lot of clustering and adding specification and yeah, having, I would say, at least what how I see it in the question, a lot of knowledge already inside of his workflow. And the question is a little bit how to make this workflow now agentic ready. And maybe I can start with this question, and then Ram, please add your thoughts on it. This is a very good question because normally we really wanted to bring everything in this kind of, let's call it rule-based automation. But when complexity increases, it's very complicated to handle every edge case. So what we see in the agentic world is that you try and aim more for smaller workflows, put them into the tool, and let the agent decide the order of execution. And I think this is the biggest difference, right? So normally you have the order of execution is defined by a very large workflow. But now with agents, and as you have seen, this agent performing the three tasks for the FE agent had access to 4 tools, right? And the agent was deciding which tools they used. And back to your question, so when you want to make your workflow more agentic ready, I would aim for more a general abstraction layer so that you build tools that you can maybe also use in multiple agents and give the agent the power to make the orchestration of all of the tools. But yeah, it's a very good question, and there's a lot to explore in this field as well. But Ram, maybe some thoughts of you as well.
No, I think that's I think pretty much summed up. I think we need to also identify what makes sense to expose to an agent and what makes sense not to expose to an agent. There are some the curse of also agent is if we give them 100 parameters, they also get confused like a human. What do I change? How does it affect? So it will get harder for the agent to learn. But if we are smart and then we design the workflow in such a way that we use the intelligence of agents to kind of guess smartly 3 to 5 parameters or at max a bunch of parameters, then there is a real benefit of getting these emergent capabilities where the reasoning model thinks, okay, I think this should not work or work. So it kind of jumps or it does more creative things. But if we expose 100 parameters, then it's also hard for an agent. So I think this distinction, what to expose and what not to expose, is also one important point.
Cool. And let's have time for one more question. So there was a question from Thomas about what can we expect from the brain in case of general knowledge, for example, FEM, right? So how well is the brain already prepared for, yeah, let's say have a load case with an extraordinary stress at one point, or would it consider to be there's a singularity here, or how good is this model already to act as a brain for an FEA engineer?
Yeah, that's a simple question, but also that's what the whole kind of AI community is working towards. Can we achieve this AGI with LLMs? Can we make it so general that it performs like human? And I think especially more attuned to the answer that, the question that Thomas asked, let's say you have a load case with extraordinary stresses 1 point. Would it consider to be a singularity or maybe a poor mesh? And this is also where we have to help these agents kind of think through this. So if we were to build this agent, we could add a responsibility or a goal that think of different failure factors or different ways a mesh or a singularity could arise and reason what could be the cost. So we do not need to explicitly tell it this is one thing, but we need to help it to kind of think through what could be the different things. And on the general knowledge ability, if we go to ChatGPT and ask what are the common sources of FEA singularity, I am pretty confident it will give us all the factors. And this is rather just textbook knowledge. So a short answer is LLMs are good at textbook knowledge, but when it comes to one specific case, we need to guide it either through prompting or by equipping some certain tools so that it can independently validate its hypothesis. That's how I see it, and I think that's how a lot of our customers who are building these agents also use it.
Thanks, Ram. And I think you mentioned it like tools, right? There could be also tools where you can use company knowledge as a tool, right? And especially if you have specific ways how to evaluate your stress results or to make feasibility checks in your domain, you can give agents also the tool to access company knowledge upfront before doing any kind of post-processing or result interpretation. So there's a lot of different things to explore for sure. Okay. Ram, it was a pleasure having this great session with you. I hope also our audience enjoyed it as much as I did. If you're excited as we are about the topic agents, please reach out to us. We're super curious to understand your use cases, to see what you want to accomplish with these new technology, and also to discuss how you can already use this kind of technology today. So please reach out to us. And maybe also if you can't get enough from us, there are 2 more webinars from the past in our agentic series. One is a more thought leadership webinar. The first, what are agents in general and why do we need this for engineering? The second one is also very valuable if you want to start and want to find, okay, what is the good starting point, which value use case you should select first. And then with this series, you have seen how to build agents, and the next one will be how to build whole multi-agent systems. Ram, any last words to the audience?
No, I think Nitesh asked the right question. So when do we need to break agents and when do we need to go for, is it a large system? Is it one monolithic system or is it modular workflows? I think that's, would also love to meet people from here on to the next webinar, and super excited to see you in other events, but also thanks to you, Daniel, and the audience here for all the attention and time.
Perfect. Thank you so much. Thanks for joining. It was a pleasure and hope to see you next time. All the best. Bye.